Let's now get to the fun part where we actually deploy and download and utilize the PriFoB solution. Just a reminder of the architecture, we say that we need institutions, for the users to issue credentials for these users, we need a gateway and we need some miners. So I actually started few virtual machines in the cloud. Here I have two miners, one institution, one gateway, and one agent. And I will actually set up one virtual machine in the cloud, and I will set it up from the start, like from zero. And I actually built up all these virtual machines the same way. But just to save time, I will only set up one, and then whenever you need to run the application, you can basically do the same steps as I will do now. So here I'm on the Google Cloud platform. I will create a new instance. Let's set this in some sustainable place. So Europe 9. I will use the Ubuntu operating system. Of course, you can run the system on any operating system because, as we will see now, like if I go to the repository here, I just go PriFoB GitHub, and then you can see that the first option you have on Google is our GitHub repo. And actually, we do have detailed information about the system here and detailed steps when you want to run it with Docker or without Docker. So basically, if you want to run it on any other operating system, you can run it directly as I will do now. Or if you face some problems, maybe with the Apple operating system, then maybe you need to run it on Docker. But the steps are specified right here, so you can run it, and then you have a step-by-step tutorial here to check exactly how the system should be behaving. So here for this tutorial, I will just use the Ubuntu, and I will select this. I will allow HTTP and HTTPS traffic, and I will create it. So now we are waiting for the instance to start. Meanwhile, we have those already running and up virtual machines. So I will start with the gateway, and let's see how it works. I will put it right here. Yes, like this. And I will have one institution, and I will have it right here. And then let's start the miner 1, and then let's start miner 2. Okay, so let's get this down a bit, and clear, 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 and clear. So here here is the gateway. So we check what we have. We just clone the repository, and we will open this folder. We will find two web implementation and CLI implementation. Currently, we are working on this, so this is an unstable version. So for now, let's try the CLI implementation. And then you will find several files here. So we will just run the Python file named PriFoB. Okay, but before we run that, let's check if the instance we started was up. So yeah, we have instance 1. So this is the new one that we just created. So I will connect to that, and let's see how we configured PriFoB on this instance. And as I said, I did this exactly on all the other virtual machines. So as we can see, we have no data here. So the first step is to clone the repository. So I will go to the available repository of PriFoB, and then we will copy this link. Then we will type git clone and then paste this link. And it's done. So now we can see that we already have PriFoB. So the thing is, we have several libraries used in PriFoB, and it depends on your computer or the device that you are running PriFoB on. Maybe the libraries are already there. You have been working on some projects before and you installed them already. So what I will do is that I will try to run the PriFoB solution, and then I will download or install all the missing libraries in this machine, right? So I will go Python and PriFoB, and now we have a problem here that there's no module called RSA. That's a library that we actually need to install. So I already, let's see, I already have some commands right here that can help you. So we run PriFoB, it didn't work. So let's see what's missing. So we do have Python. We didn't have a problem with this, but if you don't have Python, you can download it. If you don't have apt, then you can download it as well. I'm gonna go ahead and update the apt. So the code, sorry, the command for that is sudo apt update. So sudo apt update. This is for Ubuntu, of course. All right, and it's done. I will clear the screen, and then for pip3 also we need to use it in order to download the RSA. So sudo apt install again. Sudo apt install. That's why we needed to update the apt, because we need to install pip3. And yes. And almost there. Perfect. So I will clear the screen, and I'm going to go back to my presentation, and here's the command for installing the RSA library. So sudo apt install python 3 RSA, sudo apt install python 3 RSA. Is that correct? Yes. So enter, and it's downloaded. So let's try again to run Python, because this one was the missing one. 3 PriFoB, and it's done. It's run. But in case you have a problem, it gave you some problems like there are still missing libraries, then there's actually this. It seems like this library already was installed on the instance that we just initiated, so we are lucky with that. But you can use this command to download it, and if you had a problem with Tabulate, then you can download it this way. Okay. So anyway, now we run the PriFoB application, and I will exit this for now, just for now, which is option number 5. And I will go back to the 4 screens that I already initiated. So I will close this, and I will get back to the 4 instances that I accumulated here. So we said that here we will run the gateway. So once you start the application, you have 4 options: gateway, minor, institution, or student. And if you remember, we need gateway, minors, institution, and users. Okay. So what we will do is that we will start the gateway, and then we will start 2 minors, which is the minimum number of nodes needed in the blockchain in PriFoB. So we will start 2 minors. We will connect those 2 minors through the gateway, and the gateway will decide that they are connected. So they will be informed about each other's private and public keys and their IP address. And then after that, we will initiate an institution, and we will see how we can submit the DID request so that the institution will have a publicly available unique identifier, and then how the institution can submit a schema and initiate or issue new credentials. Yeah. So I will go ahead here, and I will choose gateway because we need that first. And then you need to specify, because this is upon the deployment of the solution, so you need to specify whether the blockchain will be handled in the RAM or in the secondary memory. Usually, if you want to have this for like reliably, and you expect a lot of data to be saved on the chain, then you should use secondary memory. But for this demonstration, we can use the RAM because we will just save few blocks, and it will be faster to retrieve the data from the chain. But both approaches work, and this should be determined by the gateway administrator. So we will go ahead and use one, and then we can see that we have 4 options mainly. Review miners info, which are online miners, review mining requests from miners to join the network. Here we have 00 because we still don't have any miners. Refresh the screen and exit. So I will refresh and just I will keep the gateway on and I will let it wait for miners to connect or request the connection to the network. So here we have a miner 1 and miner 2. So we have PriFoB here, so same steps. And we will run Python PriFoB. And this time we will choose the miner, number 2. And the location of the miner, as we said, miners represent the accreditation institutions or organizations that they do accredit the issuers. So each miner represents a region or a country. So let's say that miners are administered by the ministries of education for the universities, which are the issuers in our application. So let's say that this is Hungary, or this miner represents Hungary. And the BC gateway, which is the blockchain gate IP address, is this one right here. So it's provided here, and it should be input in this field. So it's 10.128.0.4 and enter. Now we have two options here that the miner needs to specify, whether you want to sign the DIDs of issuers automatically or manually. You can automate the process so that DIDs can be automatically signed in case you don't want the accreditation service in the system. In the case of universities, maybe you would need the accreditation to be included. So you need to make it manual. That means that the administrator of the miner should specify if this issuer or this institution is accredited in this country or not. So let's make it manual now, but just keep it in mind that this can be automated and the system can instantly refer to a database to check whether this institution is accredited or not, and then sign the DID automatically. Yeah. So we'll press manual, and then we have 6 options here. I will choose for now option 6, which is refresh, to refresh the screen and just stay on this reduced screen to understand what's going on. So number 4, and then we have these options. Here, if you refresh the gateway screen, then you can see that the mining requests were 0, but if you refresh, then you have 1 mining request. And if you check that by inputting number 2, then you can see that you have a request from Hungary with this IP address, and this is the public key of Hungary. And then the administrator of the gateway can either automatically or manually accept this request. So you need to select the number of the request, so it's number 1 in this case, and you need to specify whether you accept it to be a miner or not. So let's say yes. And then it does inform you now that the number of miners is still not sufficient. It's sufficient because you need at least 2 miners. So I will just press enter and refresh the screen, and you can see now that we have 1 active miner and 0 requests, and we will do the same thing that we did here on miner 2 so that we can have 2 miners, which is the minimum requirement. Miner, the location, let's say Jordan, and the IP address is 10.128.0.4, and then I want it to be manual. Refresh, Notice that the request is sent automatically to the gateway. So if we refresh in the gateway, then we can see that we have one mining request and one active miners. So let's check this. We have one request from Jordan. Number one, accept. And now there's no notations here given. So both miners were informed by the gateway. This is the first message is by the gateway that hello there, and your neighbor or your peer is this miner. And the second message was received from the neighbor or the new neighbor that hey there, I am your new neighbor. So just like pinging the neighbors. So I'm gonna go ahead and refresh all the screens. And then you can see here that we have two active miners. For a miner, you have the options to review DID requests. Schemas and revoke blocks are automatically handled in the background. You can review the local chain statistics. So if you press number 2, then you can see that you have 0 DIDs, 0 schemes, and 0 revoke blocks. And you have 3 dimensions, so you need to have 3 different statistics right here. Refresh. And you have the option to synchronize local data, which means that you need to ask your neighbors about the lengths of or the statistics of their chains, and if they have more data than you have, then they are ahead of you, and you ask them to send you the missing blocks. And then delete my local BC contact. That would totally delete everything in your blockchain. Note that again that since we declared that we need to save the blockchain in the RAM, then those 2 miners are enforced to save the blockchain on their RAMs. Okay, so I will use this 4th virtual machine to run an institution. Which is number 3. Again, the address of the blockchain. And then the name of the institution. Let's say that it's University of Sagan. And then we have 7 options right here. I will choose option number 5 just to refresh the screen. And now the institution knows that the IP address of the blockchain is this one. So whenever they want to submit DID or schema requests or revoke requests, then they communicate with this IP address. So the first step is to publish the DID. All right, so we'll go ahead and press number 1. The DID is prepared in the background, so you don't need to think about it. The public keys, the private keys, everything is done in the background for you. You just need to declare that you want to publish your DID. And since we stated on the miner level, if you remember when we set it up, that we need to have the signing manual, then then we need to check out the DID requests already received on the miner level and then manually accept them or reject them. So we will hit option number 1 on this miner, and then you can see we have 1 DID request. The type of the request is DID publication. The identifier is the name of the university, the address, and the public key, and it's still not accredited or not accredited. And for each accreditation, you need a signature. So the signature for now is 0 because this request is not signed by anyone. So you will have a full list of requests right here, but since we have only one request here, then we can say, okay, we choose or select this request, so number 1. And then it asks you if this institution is accredited in your territory or not, so you can say yes or no. I would say yes for this minor, and then I will input my name. And let's say that my position is the general manager of the accreditation department, right? So I'm signing this by my name, and I will sign this request using my private key. Now, if we check this before entering this, if we checked here, review did requests, by choosing number 1, we can see that we have no requests yet because the request is sent to the gateway, and the gateway randomly selects one of the miners, and then the miner has to handle this and then spread it around in the network to its neighbors. So until this is processed here, it will not be received by here, by this miner. So I will hit enter now. I will okay, let me just refresh the screen first, and then hit enter in this miner, and then refresh. And then let's check the did requests here. So I will refresh the screen now, and you can see that we have one did request right here. So let's check out how it looks. And you can see here that this has more data than the one we saw here, because here we have new information added to the request that Jordan, or the Ministry of Education in Jordan, represented by this general manager and signed with the private key of this accreditation organization. We can see that the signature of this accreditation organization is added to this request. Now the same thing should be done by this miner, which is in Hungary. So let's select this request and say that this institution, let's say that it's not accredited in this region or country. So no. And then the name is, let's say, general manager. Okay, and then enter. And then you can see that the block is received, and here you can see that the block is accepted and added to the chain, because now you have a block which has a header with all its information, and the body, as we know in blockchain, the body consists of transactions, and we can see that there's one transaction in here, which is the did. This is these information is taken from the did request, and we can see that it's accredited by Jordan and it's not accredited by Hungary, and this is the signature. Of course, University of Sigad is accredited in both countries, but we are just doing this for giving an example. So yeah, and then within this block we have an equivalent attribute, which is schemes chain, which is equivalent to the body and the header. And in the header and the body are immutable in our ledger, but the schemes chain is mutable. So later on, whenever this issuer issue new schemes, the schemes are added to this part right here, and you can see that we have the identifiers of this specific issuer in the header of the block, and we have a genesis block right in the beginning of the schemes chain right here, and the genesis block is generated automatically, and then all next scheme blocks will point to this genesis schema block. And then within the schema block we have the hashes revoked credentials, and this also include a Genesis block that has a revoke block for, like, it's a Genesis block, but it's for the third dimension of the DAG-based DL we talked about. And revoked credentials that were initially submitted or issued using this schema will be declared invalid by being added to specifically this chain dimension. Later on, we will see that no, we don't save the credential itself because the credential is or consists of private data. So we will only save the hash of the credential, and then the miners can actually check if the hash of the credential being asked about verifiable or not. They can check if its hash is in this dimension for this specific schema for this specific issuer. Okay, so I will go ahead and refresh the screens of both miners, and I will ask to review local chain statistics on both of them just to make sure that we have updated. And you can see that here we have 1 instead of 0 in the first dimension, and we still have 0, 0 in the other dimension. Similarly, on the other miner, we have the same thing. So we can say that the database is consistent, and miners are connected appropriately, and the did request was handled efficiently. Now, the last miner processing this request will send back an acknowledgement to the gateway, which in turn will send the acknowledgement back to the issuer who requested the service. So we will refresh this screen in the institution side. And then you can see that we have one notification here, which should be the acknowledgement of the publication of the DID. So if we press 6, then we have, this is the notification we have, the subject is the DID block, and the result is true, meaning that the DID block was published successfully.